All right. Today we are talking about solving equations. We're going to have our intro day today, and then as we get further in the week, we will start solving them and they'll get a little bit more difficult. So first off, what is an equation? So an equation includes two equal expressions that are connected by an equal sign. And the solution to an equation makes the statement true. So again, an equation includes two equal expressions and they're connected by an equal sign. And the solution to an equation means the answer. It makes it true. So I want to know, in the equation 12 plus x equals 15, is x equals 6 a solution? Why or why not? Go ahead and pause me, take 30 seconds to a minute, and think about this and try to tell me whether this is a solution, why or why not. Okay, so hopefully you tried this and you should have gotten that no, this is not a solution. So for a couple days now we've practiced substitution where we've taken in a number and we've plugged it in. So we should be able to take our 6 because it's what x equals and we're going to plug it in. 12 plus 6 equals 18. Now that I have this equal sign, this tells me that 18 equals 15. Is that true? Of course not. 18 is totally not the same thing as 15. So that means that no, it is not a solution. Why? 18 does not equal 15. All right, so we're going to go through some steps to determine if a given number is a solution. So step 1 is going to be simplify, if you would like to. And then we are going to substitute the given value. I still am not spelling that right, apparently. There we go. And then we're going to evaluate and see if both sides are equal. And if they are equal, it is a solution. And if they are not equal, it is not a solution. So again, we're going to simplify if we want. We're going to substitute, plug in our given value. If it's equal, it's a solution. If not, it's not a solution. So we have some practice here. I'm going to do the first one, and then you guys will do the next 3 on your own. I want to know, is x equals 3 a solution to any of the following equations? And then we'll circle yes or no. So is x equals 3? So I'm going to take 3 and I'm going to substitute it in. So again, we just took the 3, plugged it in where x was, and remember when we substitute, it completely replaces the variable. So the number comes in, the letter goes out. 2 plus 3 is 5, and 5 does equal 5. So yes, it's a solution. Okay, go ahead, pause me, take about 2 to 3 minutes, and determine if x equals 3 is a solution to these other 3. Okay, pause me now. I'll see you in a second. All right. So again, I'm going to do the same thing. So I'm going to plug 3 in right where x is. And then we're going to solve both sides. Substitute in the equation, evaluate, and see if both sides are equal. Evaluate just means to solve. So 15 minus 3, 15, 14, 13, 12. So we get 12 and then equals 11. Does 12 equal 11? Hopefully you said no. So it is not a solution because 12 does not equal 11. All right, let's try this next one. I don't want to simplify. I'm just going to plug it right in. Some of you might have seen and like done your distributive, and that is totally fine. You can do that. I'm going to go ahead and, no, I'm going to do that too. I'm going to distribute. Maybe I'll do it both ways. Okay, so 5 times 2x is 10x, plus 5 times 4 is 20, and we have equals 50. All right, now I simplified. Now I can substitute in x. X is 3. We have 30, because 10 times 3 is 30, plus 20 equals 50. Good old PEMDAS there. Multiplication comes before addition. 50 equals 50. So yes, that is true. Now let me just show you. So I distributed. You didn't have to. If you did 5, 2x plus 4 equals 50, and you plugged in your 3. Oops, a little sloppy there. This is totally doable as long as you use your order of operations. So I know I need to solve parentheses first, and I got to do the multiplication inside first. So I'm going to do 2 times 3 is 6. And then keep going inside my parentheses. 6 plus 4 is 10. 5 times 10 is 50. So either way you get the same answer. Yes, it's a solution. The first way I did it was distributing my 5. Otherwise, you could just plug the 3 right in. Just remember to use order of operations. Okay, now I'm going to do this one. Plug 3 into both. Okay, here you can also do it 2 ways. You could say 4x plus 1x gives me 5x's total. And then plug your 3 in right here. Or you can just plug your 3 in front of these. So 4 times 3 plus 1 times 3. 4 times 3 is 12. 1 times 3 is 3. 12, 13, 14, 15. 15 does not equal 20. Okay. Take a minute. If you need to pause me to get that down, go ahead. If you want to replay me, go ahead. Whatever you need just to make sure you understand this. Again, if you are confused, just send me a message and let me know what problem you're confused on. But make sure you have this written down so your notes are full. Okay. Now, let's go on to the next one. So this we just tried to see if a number was a solution. But now let's talk about solving equations. So in order to solve an equation, we have to, what we're going to say is isolate the variable using the properties of equality and inverse operations. And isolate just means get it alone. So you're going to try to get your variable, your letter by itself. And in order to do that, we're going to use what's called inverse operations. And inverse operations are simply just operations that undo each other. So adding and subtracting are inverses, and then multiplying and dividing are inverses. That's all this picture is saying here. Now, let me show you what I mean. I'm going to, again, do the first one, and then you guys will do the next 3. Okay, so identify the inverse operation that would be used to isolate the variable. I want to first know what my current operation is, and then what my inverse is. So my current operation happening is, well, with my variable, I have a plus 7. I have a positive 7 with it. So I'm going to say add. And then in order to add, to get rid of add, I need to subtract. So again, right now with my variable, I have a plus 7, a positive 7. So my original operation is add. In order to get rid of addition, the inverse is subtraction. Okay. Pause me. Take a minute to do these next three and then unpause me. Go ahead and start now. All right, now for this one, we have x over 5. And if you remember, a fraction is division. So my operation happening right now, I have x and then I've divided by 5. So my original operation is to divide. The inverse operation of division is multiplication. So I'm going to put multiply. Here I have x minus 8, or a x and then a negative 8. So my current operation is subtraction. The opposite of subtraction, the inverse, is to add. And then lastly, I have a 4 and then an x right next to it. So again, here you want to think, what operation is it when they're right next to each other, when they're touching, when you can't see anything? Hopefully you got that it was multiply. So right now we have multiply by 4, and the opposite of multiply is to divide. Okay. We've gone over to how to tell if something's a solution. We've gone over inverse operations. You now have some independent practice. You have 1, 2, 3, 4, 5, 6 problems to figure out if this number is a solution. And then you have 6 problems to determine what the inverse operations are. Go ahead, video is done. Take the time that you have left to determine those problems. I'm going to be looking for all of them to be complete and for all of your work to be shown for these substitution problems. All right, great work, and I'll see you soon.